Today's lesson, we are going to discussion of the exercise given. If y equal to e raised to power x sine x, show that d square y over dx square equal to 2 dy dx minus 2y. Hence, use the Maclaurin theorem, find the Maclaurin series for e raised to power x sine x up to and including the term in x to the power 3. Deduce the Maclaurin series for e raised to power x cos x up to and including the term in x to the power of 3. Given that y equal to e raised to power x multiplied with sine x, show that d square y over dx square equal to 2 dy over dx minus 2y. For this question, we are going to using Maclaurin theorem to obtain the series expansion of the function up to and including the term x to the power of 3. Always remember that we have to find the first derivative, second derivative, and third derivative, and keep going to the higher order of derivation if requested by the question. Differentiate the function with respect to x. Differentiate the y with respect to x, we obtain dy over dx. Then for the right hand side of the expression, we apply the product rule to solve. We separate the function to u and v. So we differentiate the sine x with respect to x and differentiate the exponential x with respect to x. Finally, we get dy over dx equal to e raised to power x cos x plus sine x e raised to power x. After the process of differentiation, we obtain a new equation. Search and go through the equation. We can detect a term x e raised to power x sine x can be exchanged to y. Now we have the new equation dy over dx equal to e raised to power x cos x plus y. We still apply the product rule to differentiate the term e raised to power x cos x. So we have the second derivative d square y over dx square equal to, we differentiate the cos x, we get negative sine x. Differentiate the e raised to power x, we get e raised to power x plus differentiate y, you get dy over dx. So we have the new equation for the second derivative. The equation for the second derivative, we can detect there is a term e raised to power x negative sine x can exchange to negative y, and the term e raised to power x cos x can exchange to dy over dx minus y. So after do the process for exchange the term into the y term and the first derivative, we get the new equation for the second derivative, that is d square y over dx square equal to negative y plus bracket dy over dx minus y plus dy over dx. So the next step solution, we just do the simplify for the term. So the second derivative d square y over dx square equal to 2 dy over dx minus 2y shown. We have shown that second derivative d squared y over dx squared equal to 2 dy over dx minus 2y. We'll repeat the process of differentiation with respect to x to obtain the third derivative d cubic y over dx cubic equal to 2 d squared y over dx squared minus 2 dy over dx. We apply the Maclaurin theorem which central at x equal to 0. So we substitute x equal to 0 into the every function we create or we differentiate to obtain the first derivative, second derivative, and third derivative. So when x equal to 0, f of all equal to 0. F prime 0, we get 1. F prime prime 0 equal to 2. F prime 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 0 equal to 2. Therefore, using Maclaurin theorem, we have the equation e raised to the power x sin x equal to f of all plus f prime 0 over 1 factorial x plus f prime prime 0 over 2 factorial x squared and keep going on to the higher power of x. So we substitute the value f of 0, f prime 0, f prime prime 0 into the equation. Then we simplify the equation. We get the series of the e raised to the power x sin x equal to x plus x squared plus 1 over 3x to the power 3 and keep going to higher power of x. The following part, we have to deduce the Maclaurin series for e to the power x cos x up to and including the term in x to the power 3. We just obtain the series of e to the power x sin x equal to x plus x squared plus 1 over 3 x to the power 3. Differentiate the equation both sides. So we still apply the product rule to differentiate the term e to the power x sin x. So after we done the process of differentiation, we have the equation e to the power x cos x plus e up to the power x sin x equal to 1 plus 2x plus x to the power 2 plus keep going to the higher power x. We just determine the series of e to the power x sin x. So we just exchange the e to the power x sin x to the series we obtained before. Then do simplify for the equation. Final, we have the series for e to the power x cos x equal to 1 plus x plus keep going to the higher power of x.